So this is what we're going to build. So far we've built what's called the sign scroller, this text that's coming up in front. We've built that, and what we're going to build now is the background, the text, the characters that self-assemble into this spherical shape and oscillate between that and this wavy text in the background, and this effector that disrupts the text and creates waves and stuff like that. And yeah, let's get on with it. And this is what we've built so far. Before I carry on, I just want to mention I am using 2025 360 experimental, which was released just a couple of weeks ago. It's experimental, and if you followed the tutorial as I posted for part 1 and everything worked, and then you saved your project and you loaded it and it appeared like this. The sine wave is working, but there's no characters, it's all black. This happened to me and it took me forever to figure it out. There is a bug in this version of TouchDesigner. This is normal, this is an experimental version, that's why it's called experimental. And the bug is in this math pop, which is supposed to be doing nothing, but you can see that the parameter size is 3, so there should be 3 sets of pre-adds, 3 sets of multiplies, 3 sets of post-adds, but the UI is not resetting for some reason. So this multiply is actually 1, and then the other 2 parameters are 0, so it's zeroing out the UV coordinates. That's why there's no UV coordinates. So all you have to do is just bypass this math pop, and then you'll get it. Or you can set this parameter size back to 1, and then back to 3 again. See, it should be like this. Derivative have told me that it's already been fixed, and it will be fixed in the next release. But I just wanted to let you know, if you did save the project and reload the project and it wasn't working, it's not you, it's this. Okay, first thing I want to do, let's select everything and collapse this and call this long text. And I want to make a copy of this, and let's call this grid text. Let's go into grid text and let's close these up here that we had. And let's add view this geo here. So we're going to work off this. Let's start cleaning this up. We don't want any of these LFO stuff. We don't want the pos offset, we don't want any of this, we don't want the wave lookup, we don't want these maths, we don't want the scale. In fact, we don't want, let's just get rid of everything except the lookup W. So now we have this. We're getting an error here. The error is there's no point scale and there's no color. That's fine. So this is a very simple setup. We have our text. We have the script that converts that text into ASCII codes. We convert that to a chop. That's null. And this is basically the W's on a chop. Here we have our line, and we use this to assign that W value for each point on that line, and that's basically it. And then we do a geo-instancing there. So instead of a line, let's do a grid pop. Okay, and there we have something. Let's look at our grid. It has a size. It has number of columns and number of rows. The text is coming from the bottom up, and we want to make all of this parametric. So let's start with that. Let's start with a constant chop. We want to have a, let's say, 8 spacing, horizontal spacing. We want to have a vertical spacing. And we also want to have, let's say, an aspect ratio. And finally, I want to repeat the text. So I'm going to put repeat. just so that if I want to make this a lot bigger and repeat everything. So I don't know what the numbers should be to begin with. Let's just say for spacing 0.1, V spacing, let's say 0.1, just so that they're not zero. For aspect ratio, let's say 716 by 9, or let's just say 1.6. And repeat, let's just make that 1 for now. So if you want to calculate the grid size and the number of columns and rows based on these, because that's going to be a lot easier than just trying to do it like this. Okay, so first thing we want to do, I'm just going to add a null to this straight away to reference, and I'll call that null const. The first thing I want to do is I want to take the info, the length, and I want to take the square root of that. So that would make the number of columns and rows. If I take the square root of length, that would make that square. So let's just select the length and put that into a math. Here, let's take the root, so 20. Let's say put a null, and let's call it null grid params. And on the grid, if I use this for the columns and the rows, it's going to be roughly, well, it is square in the number of columns and rows. And if we make, you can see we're starting to get somewhere. But we don't want it to be square. We want to use the aspect ratio. So what we can do is, in fact, let me just take these and put them here. This math, also, we took the root. Let's then multiply it by this aspect ratio. And I want to rename this because it's going to get very messy. So this is going to take the square root and then aspect ratio. So this is actually, I can now rename it, rename. And we will rename this to, this is the number of columns on the X. Again, I did a square root, and then I multiply by the aspect ratio. I can rename that to columns. To find the number of rows, we can do another math, and we can put both of these in. And this time we want to combine the chops by dividing. Wait, no, sorry. This is obviously dividing the same thing by itself. We want to divide the total length. So this is select length. This is the total number of characters. We take the square root, multiply by aspect ratio, that's the number of columns. Then we take the total length divided by the number of columns, and this is going to give us the rows. And so let's rename this. This is the number of rows. And then we can merge these. But I want the columns to be first, horizontal, so let's do that. Let's try this, cols and rows. Let's go back here. It's got an error because we don't have length anymore. So that should be cols, and this should be rows. And now, let's see, where's my const? If I say aspect ratio is 1, okay, it's a square, that's good. If I make the aspect ratio 1.6, so now we have more columns than rows, which is good, but the overall shape hasn't changed because we just changed columns and rows, but we haven't changed the size, so we need to make the size dependent on this as well, using H spacing. I could do that just here. I could just write here that this should be that times H spacing, but I can also just do it here with another math. these are my null constants. From here, select, I want to select, do a wildcard select for the spacings. So first of all, I want to call this math divide, rename rows, rename calls, and this is going to be a multiply. So here I want to combine the chops. If I did combine channels multiply, it would multiply these two with each other and these two with each other, whereas I want to multiply 8 spacing with calls, V spacing with rows. So I want to do combine the chops multiply. And so now you can see, like, let's make the V spacing 0.2. You can see that that's being multiplied by 0.1 and that's being multiplied by 0.2. I'm going to change the order of this. Just, it won't affect the numerical, but it'll affect the name. So now that's called H spacing, that's called V spacing. And then I'll add a rename here. And I will rename from question mark spacing to question mark size. Question mark is like asterisk, whereas asterisk is any number of characters, whereas question mark is a wildcard for only one character. So now I've got H size and V size, and I've got calls and rows, and let's just add another merge. And now in our grid we want to use H size for there and V size for there. Now let's go back to our constant. And I can change the aspect ratio. Yeah, looks good. That's the horizontal spacing, vertical spacing. So now let's do play with this repeat. Now that we've got this working, all we need to do, you'll see what this does, add another math. And this math, we just want to multiply. See? Those are empty. I'll come to why that is. But first, let's do this in a thing, repeat, and add that there. Let's, okay, and rename that math. Oops. I'm going to color this red so I know that that's the thing I want to edit. So now if I play with repeat, oh, that's not repeat. Okay, yeah, let's make that 1 point. Wait, that doesn't look like a 1.6 aspect ratio. So if I say 2, that doesn't look like an aspect ratio of 2. And in fact, if we look at the number of columns and rows, you can see that it's almost, it's 4 times. And that's because I shouldn't be dividing by the aspect ratio, because if I divide by the aspect, so if I multiply by the aspect ratio here and then divide, we're effectively taking the aspect ratio into consideration twice. So what we need to be doing here is, instead of multiplying by the aspect ratio, we need to be multiplying by the square root of the aspect ratio. Because then when we divide by that number, that aspect ratio is coming into effect again. So now yeah, you can see 29.33 to 14.66. That's roughly 2. And this is going to be not perfect, but very, very close. And so now that's an aspect ratio of roughly 2 to 1. Let's go back here, make this aspect ratio 1.6. The other thing we can do is, you can see that the text isn't fitting. That's because stuff is being rounded. And we need to make sure it's being rounded up all the time. So this one here on this math, this one we can round. So that's going to round to the nearest integer. So 26.23 is going to become 26. Yeah. This one we want to round up. No matter this is going to round up anyway because it's 54. It's greater than half. But we need to do sealing. That will round up to 17. Even if it was 16.01, it would round up to 17. And that makes sure that we have that extra row, and then the rest of it is blank. So we've got the full text here. And then the repeat, let's increase this repeat. You can see it's adding more tiles, but they're all empty. Now let's address that. The reason why they're all empty is here in this Lookupchan. I think we covered this in the other tutorial for another reason, but the extend is hold. This is where we are mapping the W's, which are the characters. Here we want to make this, instead of hold, we want to make it cycle. That's to the left, which will have no effect because we're not going to the left, but on the right, we want to do that. Now we can increase the repeat, let's say 2. And it's just basically repeating and repeating the text. And let's say we want the text to start at the top. Let's put that back to 1 for a second. See the text, we want to start at the top. So we can just simply flip this vertically. So these points appear at the top. And I'll just put a minus here. And there the text at the top. Okay, and to make all of this tidier, I am going to select all of this and collapse it and call it grid params and add an out. And I like to call things capital out, a convention from Houdini. And now this, I'm going to edit it by hand. And I'm going to very quickly edit this. I might speed this up in the video. Just to add my parameters, my consts there. And set the ranges, defaults, let's set some defaults. Okay, nice. Now we've got this. How do we explode this into a ball? Let's create a point generator. By default, this is generating loads of random points on this sphere. Actually, in this sphere, it's the distribution is volume. I can also do surface. Now it's loads of random points on a sphere. And we can also say it to be random or not random. So what we want to do, let's just try, for example, putting that in there. So we want to do it before the Lookupchan. If I put it after the lookup, the W, then we just have all of these points, but they don't have W's. So we need to make sure that we put this there. And let's make the radius a bit bigger. Okay, so there it is. There is a sphere with all of these points. So we want to be able to basically crossfade the positions between that and that. So the first thing we need to do is we need to make sure that there is the same number of points, so that for every point on this grid, we have a point on this sphere. So I want to link this, the number of points, to the number of points of this grid. Now I could do maths again from here. I could do the cols times rows, etc. But in case I change the way, I'm not going to, but in case I do change the way that I build this grid or do something, whatever, I'm actually just going to do, like if you look at the Python help for this. Okay, annoyingly, I have no internet. My internet's just died, never mind. Basically, I was going to show the Python help for a grid pop, and actually not for a grid pop, just a pop in general. So here, in the number of points, I want to write pop, fetch the grid, and then num points. That's just a built-in method. Oh, maybe not. Is it a function? Yes, it's a function. I mean, you could also actually do, let's say O equals pop. Does this work? And then dir O. And yeah, you get a list of all the methods and properties that you can call, and this is not a very nice way of navigating, but you can see there's a num points method there. Anyway, so now we have the exact number of points, and we just now want to crossfade between those positions and those positions. And what we can do, we want to do this before the W there, because we're going to assign the W to both. If you wanted to assign the W's to the sphere in a different mechanism to how they're assigned to the grid, you can do it after. You could have two Lookupchan or two lookup W's and then do what we're about to do here. But what we're going to do is a math combine, or we can do mix. We use this a lot, but this time we're going to give it two inputs. We're going to use a mix from A to B by some arbitrary number. So the inputs here, you can see that there's two inputs. The first input here, this is the first pop, we're taking all of the attributes. So it has all of the attributes Pn text from this. From the second input, we want to take position, and we want to rename it to P2. Let's create another constant chop, and let's call this shape mix, and this is going to be 0 to 1. So we want to mix from P to P2 and then right back to P with this shape mix. I'm going to call this constant. And put that there. Now, if I go to 1, you can see it's going to the sphere. I don't want the sphere to be random. I want it to be like this. Okay, also, you can see that all the faces are pointing out. So I'm going to facing the same direction. I want them to be on the normal. I'll fix that as well. But before I do that, I want to talk about what I just did, because I don't know this for a fact, but what I'm doing is I'm mixing from P to P2 and I'm writing to P, and this number is how much I'm mixing by. So hopefully this should make sense. However, what I've noticed is that the performance of this can get quite slow as you increase the number of points. I noticed this in another project. What I would have expected is that this number is sent as a uniform. So it's sent only once, it's sent as a uniform, and then internally, for every point on this incoming pop, it runs some compute shader, and then it mixes between that P and a P2 based on this uniform. But I found the performance to be really, really slow as you increase the number of points. So instead, you have to explicitly make a uniform. So if I say create a shape mix uniform and here bind it, and then here we use that shape mix uniform. So this shape mix now is not an attribute per point. The thing about an attribute is per point, whereas a uniform is per entire run. So if you do it explicitly like this, explicitly create a uniform, then I found the performance to be a lot better. I don't know if this is a bug or if it's intentional. Maybe someone can explain that. So that's that. Now how do we fix the normal letters? I want the letters to be on the surface. Normally, if you pardon the pun, the way we make a sprite, or any object for that matter, align in a particular direction, we use this on the instance2 page, the rotate to vector, and the forward direction. This is a convention, a -z, and we say point the -z along the normal. And if it appears flipped, we can make it along the +z. But I've just done that and it didn't work. So let's investigate why it didn't work. Here is our point generator, and let's go in and have a look at the normals that are being generated. Is this... So I think this might be a bug. I've discovered that if I, press P and I click on these, none of these seem to do anything. Again, this is experimental, maybe that's why. But sometimes this works. So show me the normals. Okay, so the normals are working. So the normals are correct. Why aren't these aligning? Because it's not making it through. These are the normals here, but we're taking the normals from here because this is where the main flow is happening. We are just taking the position, saving that to P2, and then we are mixing from P to P2 by shape mix. But the normals, if we look at the normals on this one, they will all be pointing forward because it's taking the normals from this pop. So what we need to do is we also need to take n and we need to save that to n2, and then we need to do the same thing here. We need to mix from n to n2 right back to n by shape mix, and hey presto. And you can see they are actually flipped because it's not -z that we need to be pointing in n, it is actually +z. And there we go. So now when so now all the normals are pointing forward as I go into that. I think I want to make this a bit bigger actually. The size, yeah, and we're going to play with the size of the particles as well for different things. Okay, so we've got that. Now let's put this on an oscillator. Good old LFO. Let's call it LFO shape mix. And this is going between -1 and 1. We don't want that. We want it to go between 0 and 1. So I'll give it an offset of 0.5, an amplitude of 0.5. And this is way too fast. I want to slow it right down. And let's link that on to this. Okay, what I don't like about this is it's just moving too much. And let's just look at something. This is what's happening here, and let's also map this amplitude 0.5, offset 0.5, and let's shift the phase a bit, 0.25, so that is going from or let's make it, it's going from 0 to 1 to 0. This is the same thing. It's a sine wave. That's also a sine wave. And this is not the shape that I actually want. What I want to do is I want it to hold at the ends, and I actually want it to spend more time at 0 than at 1. And one way of doing this is using a function and then do input to an exponent. And when you have a number that's within the range of 0 to 1, if you make the exponent greater than 1, then you're pulling things closer to 0, and if it's less than 1, you're pushing it closer to 1. This is maybe easier understood with, so these are kind of called wave shaping functions. 0 to 1, if I put that there, you can see if my exponent is less than 1, it's going quicker to 1 and spending more time closer to 1. If it's bigger than 1, then it's spending more time closer to 0. So one could use this, but actually TouchDesigner has a nice thing called S-curve. And with the S-curve, you can control, well, first of all, you can add some prepend, which spends more time at 0, spends more time at 1, and then also you can control how quickly it goes from 0 to 1. And yeah, there's a whole bunch of things here that are really nice to control. So I think I want something, in fact, like this. Let's reset that. Let's actually put that there and put that. Oh, damn. Okay, I should have created a null. Let's create a null. And reference this. So now I can play with this. You can see it's spending a lot of time there. Whoop, goes quickly there, spends some time there, but it should spend less time because, oh no, let's do a bit of bias. Spends a little bit less time there and then comes back to that. Okay, now let's do some other fun stuff like color and scale. In fact, we still have these errors that there's no point scale and there's no color, so let's add those. For color, let's create a random color, and we want to create a random attribute. We want to set this random attribute, not so, as you can see, by default it was doing it to P, but we want to set the output attribute, let's call it color, and immediately they all have a completely random color because we are randomizing between 0 and 1 for RGB. For now, let's create that a bit more subtle, so there's just a little bit of subtle variation. We instantly saw color because already on our instance, because we copy pasted this from the previous tutorial, we already have color here on instance 2. So that's color. Let's do scale. Now for scale, I'm not going to do random. Let's create just a normal attribute. And there is a built-in, if you recall, I can call memo p memo, I can give any names, arbitrary names, but we can also create a point scale. It defaulted to 0. You can see that point scale is already in effect because, again, on the geo, on the instance 1 page point scale, we already have it there. Let's quickly rename these. Random color, random p scale. So now what I want is, I want a different scale for the grid and the circle. So one way I could do that is I can create different attributes here, just like I did with P. Let's actually call this math mix max shape mix. Just as I'm mixing P to P2, I could also create a point scale here and a point scale here, give them different values, and then mix them. But I can actually do it here as well. So let's create a math combine. We want to do a mix, and we want to mix from, let's say, 1 to 2 with shape mix. Oh yeah, we need to create a new uniform again. So shape mix, and let's put that there. Come back here. Shape mix. Again, shape mix is a uniform. It's not an attribute per point. It's global. And we want to write this to point scale. Now I have a suspicion maybe putting 1 and 2 here is maybe also slow. Maybe we need to create uniforms and call it grid scale. No, that's not color. Call it grid scale 1 and call that sphere scale and call that 2. And then instead of 1 to 2, go from, oh yeah, from grid scale to sphere scale. Look, I don't know if this is more performant, but now hopefully you can see. Let's override this. So there, the scale is 1, and as I go there, they're a lot bigger. So let's go back. This is math mix scale. Put this back on auto. Oops, wrong one. And yeah, that's way too big. Let's make the tiles more. The repeats 4. Okay. So now I've just made the repeat 4 on there. It should be 1. 1 looks good, but when it becomes a sphere. Okay, let's make the sphere effector. Sphere pop. Let's create a null, just so we have something there, and let's show that as well. Oh, we can't see it because that is showing specifically Geo1. Let's show grid text. Okay, there's our sphere. And for now, I will just create a noise. I mean, I'm going to link this to the mouse, but later. But for now, I'll just create a noise. Chop txty, and let's null effector. Make this a time slice. Put this on translate X, translate Y. Oh, and let's set the shape mix to 0. Okay, so that noise needs to be bigger. And the period needs to be slower. For now, perhaps that's fine. I want to link the speed of the ball to, sorry, the size of the ball to the speed. So let's take a math, call this length, and combine channels length. Rename, actually no, sorry, that's, I forgot, ignore that. First we need to do slope, which is find the speed. So this is finding the speed on x and y. Then we do the length. So this is now actually finding the speed. And so let's rename. To speed. So slope finds the speed per axis, and then we take the length, and that finds the overall speed. And now we can merge. Oops. And here on the uniform scale, let's put speed. Actually, no, let's add another math and call this scale. And what I want to do is insert a rename here. This is going to be scale. Rename to scale. And let's also add speed. So we have. So now speed is the actual real world speed, but then I want to map that to an arbitrary value or a nice value. That's going to be my scale. And in my sphere, I want to put that scale. So not from there, from here, scale. Okay, so that is null effector scale. And this is null effector XY. Okay. And now here I can map. I don't want to spend too much time on this because I'm going to put it on the mouse later. The mouse speeds are going to be very different. But what I will do is I will add a limit here. Like that's way too big. So limit clamp minimum, let's say 0.1 and maximum 3. And let's also add a lag because it's very jerky. And let's scale this down a bit so it's not so sensitive. Okay. And instead of displaying it, let's template it. And we don't need it to be. This is only for, this is like a gizmo. This is only for showing. We're not actually going to use the sphere. We're going to use these values, and you'll see how shortly. So we don't really need these details. Frequency, let's lower this. So we're not actually going to use the sphere. We're going to use these. Okay, this is just so that we have something there. The next step, we are going to use, what we want to do is, based on this sphere, we want to select a bunch of points and influence them in a way. One thing we could do is we could run through it, we could write a shader, run through every single point and look at its distance to this sphere. We could do like a kind of softening, and then we could do an if something is inside, do this, if it's outside, do something else. It just so happens that there is an exact pop that does that, which is called field. So what the field does, it uses this attribute and it uses this effector type. So there's a whole bunch of built-in things here. And then it creates a new attribute. And it can do a whole bunch of stuff. It can do quite powerful things. Like there's a whole other pop that you can give it that has lots of extra information. But in our case, what we want to do is very simple. It's exactly this. So we want to use P. We want to use a sphere. The radius, we want to use this scale. Let's put that there. Okay. And then the position, we want to use Tx, Ty. So again, this pink sphere that we have here, this has got nothing to do with it. This is just so that we can visualize what's going on. And what this is doing is it's writing the output to something, to an attribute called weight. And let's visualize again our points. Is this updating? Because sometimes it's not updating. Let's just double check this. Yeah, it is. Okay. So you can see that the weight is 0 for lots of things, but if I scroll, there should be some. Okay. Let's make this a lot bigger. Let's get rid of that and make the math scale. Okay, now you can see that a lot of them are 1. They're changing between 1 and 0. So anything that's inside is 1, anything that's outside is 0. Let me do this. Let me undo what I just did. After this field, let's add a math combine. And let's just do A. And let's use, see now we have a new weight attribute, and let's write that to point scale. So now you can see anything inside that sphere has a scale of 1, anything outside has a scale of 0. So let's slow down this movement actually. Let's so I've just made the noise period 100, so it's moving super slow. And now because it's moving super slow, the sphere is tiny, so I'm going to multiply this. No, actually I'll do the limit minimum 3. Okay, let's make it 2. Perfect. Go back to the field. There is this transition range which you can soften the edge. You can see when it's at 0, it's a hard cutoff. If you make it 1, it's quite a soft thing. In my experience, I actually quite like it even bigger, like this. And there's a transition type which is linear. You can do smooth step. So linear would be it's 1 here, and then there's a hard cutoff as it comes down, and this just kind of different ways of smoothing it. So now that we have this information, we don't want to put it on the scale, well we could do, but let's think about what other things we can do. For example, the first thing we want to do, let's make anything that's in there bigger and anything that's outside its normal size. So instead of doing this, instead of overwriting point scale, we want to add to point scale. So we can do A plus B times C. Well, first of all, let's do A plus B. So what would A plus B be? It would be you take point scale and you add weight to it and you write back to point scale. So now everything that's outside is the normal size, anything that's inside is point scale plus that. But we don't want that, we want A plus B times C. So we can multiply this weight by something, so multiply it by 5, then anything that's inside is the weight plus 5, and you can see this small smooth thing. Now again, I don't know if writing 5 here slows things down, and if we need to create a uniform. I'm not going to do that, it's just too much work. Hopefully this should be interpreted as a uniform. Yeah, let's just go back to something. What was it? Something like 5, and so let's make the period 5, math scale, yeah, limit, make that 0.3, and yeah, 5 was a bit much, let's say 2. Okay, let's make that sphere a bit bigger by default. Yeah, that's too big. So maybe 1 is good. And also let's call this field sphere math. Whoops. What is this one doing? This is doing sphere stuff. Let's say we want to randomize anything that's inside this. So to randomize things, we can use a noise. see, if you look, noise immediately is by default affecting the position. Let me increase the amplitude. Okay, so by default this noise is affecting the position. It's not because of the noise lookup attribute. I think I covered this in the previous video. The noise lookup attribute is what is being indexed into the noise. We do want to do that, or that will create more coherence, as you can see, especially if I increase the period. You can see that there's more of a pattern in the distribution of the noise because we're using P. Instead of P, if I use the point index, which this one doesn't have, but we did it in the last video, we can create it more randomized. But the reason why it's adding to P is not because of this, it's because in the output we say add to P. Now I could say add to memos W. We don't notice any difference because the noise amplitude is 1 and W is an integer. So if I made this, say 100, then you can see it's all random characters. If I say 10, then each character is plus or minus 10. If I say amplitude 2, then each character is plus or minus up to 2 characters. So if I said, 100, and let's go to the transform, and here add the classic abs time.seconds. So all the characters are randomizing. But how do I limit this to everything that's inside here? Now the way I do that, this is a very powerful way of working with noise. First of all, I want to rename this from noise to noise W. In the output, instead of adding to noise W, we want to do nothing. But we want to create a noise attribute, and let's call this noise W because we're going to do a few other noises. So you can see now here, this is, again, we're looking at our points attributes. There is a noise W attribute. Every single point has a noise W attribute. The text is correct. The text is fine. Now, in our math, we're adding to the point. Let's add another one. I could add another math, but I'm going to do it all in the same one, which is like all the sphere stuff. What do we want to do? We want to do, well, let's write it down. We want to add to the W. We want to say W equals the existing W plus weight times noise W. Again, A plus B times C. Exactly the same. A plus B times C. So we want to take the W, which is, I called memos W. We want to add to that the weight times noise weight. There we go. I think I also added in my original video, just looking at this looks very flat. I think I added a bit of Z. So if it's inside, I made it come out. So let's go back to the math, add. We want to do A plus B times C. We want to add to P dot Z. So you can do this. You can write to just one component of position. We want to write weight times an arbitrary number, 5, and there it's adding. Let's make the scale weights more. So you can see it's working quite nicely. Let's also add a little bit of noise, just in general, to the position. And I want to add this noise, like just to the position. And instead of using the noise, let's use curl. Make the period a lot bigger. I'm going to stop this because it's slow. Back to the noise. Let's call this noise P and give it a bit of movement at time dot seconds. Okay, way too fast. Okay. Let's see what this looks like on the circle. So actually I don't want this noise on the circle. So let's take this out of there and put it here before the mix. So this circle doesn't have, the sphere doesn't have it, and if I go back to the grid, then it has that noise. So one thing I noticed is that just pushing on Z isn't nice, because when it's a sphere, it's doing kind of weird things. It's just pushing on Z. I want to be pushing it out instead of this one here. And also, let's go back to that. I want it to open up more. So what I can do, this is, so here I've got my field. Here I'm creating a noise W. Let's create another noise. In fact, I'm going to take this noise, paste it, give it a different seed, give it a much bigger amplitude, put that in. Oops. Yeah, give this a much bigger amplitude. And I want this noise to only take effect inside the sphere. So again, on the output, I don't do anything, none, and I call this noise P. And here, instead of adding to doing this whole thing, I want to do P weight times noise P and write that to P. And let's call this noise P sphere. And let's see if that worked. Let's make this amplitude 10. Yeah. So something weird is happening there. Let's say the noise size, oops, the noise size is a vector. Parameter size 3. Okay. And actually now we've done that, we could output a curl. Let's say curl, noise curl P. And let's use that. Oh, we don't need noise P. Noise curl P. Okay. That is way too much. Noise, go back to the noise. Bring the amplitude down. Let's try. Let's start rendering this. We can close that. Oh, actually, before we render this, let's add a mouse chop. And connect that to this. Let me do that. Add a null. Connect that to that. Okay, yeah, I need to map all the mouse coordinates and stuff. So let's quickly do that. add a math. Okay, that'll do for now. And the other thing is, let's add a spring. Damp it. Okay, that feels a lot nicer. Okay, now let's have a look at the speed. It's going up to about 50. We don't need that lag anymore. Let's get rid of that limit just to see. Whoa. Yeah, let's put the limit. We want a minimum size of okay, yeah, that looks good. Let's now let's tidy this up a bit. All of this can go into mouse effector. Let's add a geo to this. Actually, for rendering, let's give it a bit more. Yeah. And create a fong. I'm gonna want this to be somewhere around there. Okay. And let's create a camera, a light. I've got control down pressed, so that's how I can create multiple things, and a render. And let's make that a top. So there's my camera, my light, my render. Got a warning. Oh, alpha. Okay, yeah. So this material, I need to enable alpha blending, because that's going to need to be on as well. You can see when in this fong material for the text, you know, they've got the black rim. You need to enable the blending. We might run into issues with sorting, but we'll cross that bridge when you get to it. So there's our render. Let's create a null out. I want to display that, and there it is. Oh yeah, I usually have this turned off, so I don't like it in the background. So right click, display backdrop tops. I usually have that off, but I have it here. So my camera is probably inside the F5. Let's say, well, not inside, like too close. Let's move it back a bit. And let's also give it a background. I want to give it a ramp. By default, the ramp is multiplying. I want to put the ramp underneath. So there it is, the ramp is behind. Back to the ramp, make it vertical. This side, I want to make a kind of blue. And then this side, I want to make kind of pink. Okay, something like that. Now I also had actually created a, let's say, a null and call this cam look at. And then this camera is going to be looking at this and create a noise. TXTYTZ. Make it a time slice. So let's call this cam x form. Actually, let's call this target x, target y, target z, and put these on here. Okay, that's way too quick. And let's make the amplitude and yeah, randomize the seed again. So, okay, that's our target. It's slowly moving around. We also want to bring in the side scroller. And yeah, this sphere I want to keep out. And all of this I want to collapse. And let's call this grid text. This is giving an error. We want to get this from grid text. Okay, so this is a bit cleaner now. Everything with regards to the grid is happening here inside grid text. There's my sphere. We don't need that null at all. That's the effector. There's a camera. Okay, we lost this null points. Let's add an out. And this, let's take, put it here. And we're going to take grid text. Actually, we didn't need that out. We can just do it like this. Okay, this is a bit cleaner. So here we've got our grid text. This is just creating the points. It's just creating points. And we're instancing outside. And the reason I did that is because I'm going to go and get this long text. This doesn't need to be called grid text anymore. This can be called basically main. I'll take this long text. This was our side scroller. Take that, and I'll put it here. And I can merge the points from here and here. So let's do that. Let's actually, yeah, we have an out on that. Let's add an out on this. And then let's do a merge. And let's call this null points. And now on this, yeah, let's go back to the null points from here. Okay, we have something. And now we just need to tidy this up. These colors are a bit too colorful in the long text. Let's see where that was. Attributes cal, noise cal, okay. Attribute, yeah, that's too much. That's without any noise, that's a little bit of noise. Okay. Also, the overall thing is quite dark. Where's the light? Let's increase the dim. Oh, you can see that there's a sorting issue. This is because the way alpha blending works, I guess I might do a whole video on that. Even though we have blending enabled on this material, the issue is there's something called the depth buffer, and the pixels are drawn. So let me just freeze this here. This is drawn, and here there's information saying this pixel has been drawn, and it's, you know, it's quite close to the camera. So when it's rendering the stuff behind it, it doesn't actually know that it should be transparent. And so it says, oh, I'm not going to bother rendering that bit behind it because it's not going to be visible. It's an optimization. So what we need to do is we can turn off depth testing altogether, and it's just rendering no matter what. So that's a very easy, or you could keep depth testing on because it might actually interfere with the sphere. Put depth testing on and just disable writing to the depth. The difference with that is that it's going to check for depth if something else is written. For example, if the sphere has written the depth value, and if what needs to be drawn is going to be behind the sphere, then if depth test is true, then it won't render it. But we have the right depth off. If that was on, then we have that artifact issue, but we turn that off. Yeah, it's quite complicated. I might do another video. Okay, so we have that. And I think also we can add a bloom. It's important to add the bloom before putting in the background. And the other thing that we can do is take that out, transform. Let's make that 2. Blur it a bit. And then composite. But we want to do screen. Yeah, that's way too strong, so let's add a level and bring it down and maybe blur a bit more. Okay, I think that's pretty much, that's it. I think, oh yeah, first we need to put back in the grid text this. And, oh, I think, yeah, the lighting could do with some work. And also the camera we can, but I think this video has been too long, so I'm gonna maybe stop here, and I might do some more stuff in another video. Another thing I want to do actually is I had like another wave rippling through that flips the characters, and then the other thing I want to do is go through replacing a lot of this with a single shader. Basically, you know, there's a lot of nodes here. All of this could be done in one shader. And another thing I want to do, for example, is add a kind of fog so the particles that are further away are slightly softer. And I think I'll do that in the next video. So yeah, thank you.